Okie dokie, everyone. Well, I'm still drying off. For those of you who are watching this online, I think you don't get to see that I'm wet on one half of my face, but that's great. I think you're getting the better version of this presentation. So yeah, thank you very much for having me here. I'm Dr. Tommy Thompson. This is AI in Games, and this talk is Don't Forget NPCs Need Love Too, because we already talked about AI from a generative context today. We're going to be swinging all the way back to the other side. So who am I? What am I doing here? Why is he Scottish? We'll answer all these questions right now. So I'm actually a former university lecturer and AI researcher. And about 10 years ago, I started making YouTube videos on the side for a laugh. I thought, how hard can it be? 10 years have passed. My hair wasn't this color when I started. But subsequently, AI in Games has actually built out a really good reputation in the games industry. Over the past 10 years, we've released over 100 videos. We've amassed a subscriber count of around 250,000. The videos have had around, I think, 14 million, 15 million views. I can't remember. It's been a hot minute. This has fundamentally changed the course of my professional career to where I am today. On that note, what I actually do is a lot of my time is spent just trying to share information on how game development works and trying to remove obfuscations where we hide knowledge and it's hidden behind paywalls and everything else. And so I try to go out my way either through our YouTube content or through our weekly newsletter to just try and help people understand how AI exists within the games industry. And that seems all the more relevant now when AI has decided to attack the games industry, I would argue, in some contexts. And it has led to so much misinformation, miscommunication, and a fundamental lack of understanding of where we're going. Critical thing, YouTube, newsletter, like, subscribe, please. Thank you. Actually, the bulk of the work that we do is we actually work now with game studios, providing training workshops of various sizes and scales. We actually consult on a variety of games to help people with game productions and helping them integrate AI, everything from our NPCs suck to we're trying to figure out how to use an LLM and put it into our game. We do a very wide range. And as you can see, we work with some of the smallest, but also some of the biggest companies in the industry. And last year, we actually founded our own conference. So after 10 years of producing YouTube content and the business being around for 4 years, we launched the AI in Games conference last year in London. I'm really, really proud of this. And I felt like Dev Games was an event that was founded last year. And it came from the same idea that we don't have enough events in Europe for our community, for the people in this space to be able to meet each other, to share ideas and the like. And last year, we were really fortunate to have a variety of speakers from Guerrilla, Saber Interactive, Electronic Arts, Unity, Epic Games, Riot Games, AWS, and a lot more. We have over 20 talks available for you to watch for free over on the AI in Games Conference YouTube channel. And yeah, we literally, as 3 hours before I jumped on a flight to come to Rome yesterday, we announced this year's event. It's running for 2 days at Goldsmiths University in London. I'm really grateful to a whole horde of awesome companies that are putting their money behind this to help us make it a reality. The call for speakers, if you want to present, is open now until the end of July, and early bird tickets are also available. Student tickets, critically, because thanks to our sponsors, are capped at no more than 120 euros. So if you want to come down, we'd really love to see you there. All right, enough of that. Stop shamelessly plugging and get on with the talk. So today I'm going to talk about game AI specifically. And we hear AI in the games industry an awful lot at the moment, but when I say game AI, what do I actually mean? And I'm going to start here because everybody just really loves a good taxonomy. This is an old one. This actually dates back to 2024. I need to update it. But this was me trying to help people understand, because I keep being told how AI fits in the games industry. And pardon my French, fuck you, I'll tell you how AI fits in the games industry because I've been in this for 20 years. And today, I'm really going to be focusing on one corner, and that's here. So this is what we traditionally call game AI, AI for the player experience. And usually it is part of how we get AI to actually play a game with the player. So game AI is largely used to represent this notion of AI used in the context of play. And as we'll discuss in a moment, when we're talking about game AI, we're not talking about anything that is machine learning. We're not talking about generative AI. And those are topics I will return to later. Interestingly, I list a couple of games here that are kind of synonymous with the birth of game AI for a number of reasons. Doom, because it was very influential in showing how to structure behavior, particularly in three-dimensional environments. Half-Life also then took the ideas from Doom and really reinforced it. Quake 3 is the first game that uses what we now call a nav mesh. Up until then, 3D navigation was awkward. And yes, the area awareness system, you can still go onto id Software's GitHub and actually look at the repository for the original AAS system. It's a really cool thing. I haven't made a video about it yet. Also, critically, the term game AI is a self-identifier. And this emerged because game developers got very fed up of academics telling them what is and isn't AI for games. And so they said, fine, we'll just start calling it game AI. And now we have a new wave of people telling it was what is or isn't AI in games. I'll rant about that later. So yeah, what do we actually use game AI for? First and foremost, pathfinding, right? Just getting characters or other systems from one point of the game world to the other. Nowadays, as I mentioned, we talk about navigation meshes that are really useful for us to do that. One here is just me playing around with Unreal Engine in the bottom right, using just nav mesh volumes. But on the left, that is a nav mesh system, tiled nav mesh system built in the Decima engine for Death Stranding. And critically, we're trying to just figure out how to get from A to B. Of course, it's never that easy, particularly as games increase in size and scale. So on the left hand there, that is actually a hierarchical A-star pathfinding algorithm that was used again in the Decima engine by Guerrilla for Horizon Zero Dawn, particularly for the flying machines, where it actually has to pathfind at multiple layers of granularity. So it starts with a very high level abstract path on the top right, and then on the bottom left, sorry, and then it kind of gradually finickets down to something much more granular, much more precise that fits the geometry. Meanwhile, Death Stranding actually has an underlying road network to allow for characters to figure out how to get from one side of the game map to the other, because anyone who's played Death Stranding knows, one, it's really weird, and two, it takes a long time to get anywhere, which is part of the charm. You know, of course, decision making, and that can be anything from usually strategy games and the like. Usually we're thinking about search algorithms once again, but often we are tightly constrained by the design philosophies or challenges that are built within the game itself. So on the top there, that's Monte Carlo tree search, which has been used in a variety of Total War games to try and simulate the possible outcomes of diplomacy and then what impact that's going to have on the game. And it has to be able to do that very quickly, but at a high degree of accuracy, which is actually really difficult to do when you consider the total problem space of one Total War match. On the bottom right, you have The Sims, and that uses a variety of constraint-based search algorithms to figure out whether or not a sim can do something in a particular part of the game map, but also whether it can do two things concurrently. So, for example, like actually giving a talk like this and then stopping to have a sip of water and pointing it away from yourself for fear it might soak you again. Previously, in the older Sims games, they couldn't do that. They would actually have to give the talk and resume the talk once they'd finished having a drink. So this notion of concurrency was actually a very big part in The Sims 4. Bottom left, that's actually constraint-based content generation, but I'll come back to that in a second. That's over in Townscaper. But more often than not, people think about NPCs, right? So going back to the early 90s, we took finite state machines, which are a very well-worn concept in computer science, dating back to the 1940s. And so I talked earlier about how Doom and Half-Life in particular were very influential in that. Structured behavior where you say, well, in this state, this is what this character does. And then there are rules that dictate how it can transition from one behavior to another. These are still used today in AAA games, though more often than not, we now use hierarchical finite state machines where we group common collections of states into a broader behavior, and then those behaviors are individual states that you can transition between. Everything from The Last of Us Part 1 and to the modern Doom trilogy all use hierarchical finite state machines. Not particularly complex, but hey, it works. The other big alternative to this is behavior trees, which for any of you who use Unreal Engine, that is your AI tool by default. These were largely popularized by Halo, or directed acyclic graphs, as they called it when they built them in Halo 1. Halo 2 is really the game that defined what we now consider a behavior tree going forward. And I would argue about somewhere between about 60 and 70% of all AAA AI is largely built with a behavior tree these days. On top of that, we also had, particularly in the mid-2000s, planning became very common. And actually, Piero briefly mentioned planning as part of the generative models that they were working on in their project. Here, we're typically talking about very tightly constrained search, where we have a set of rules dictated by the human designers, and that's a critical part I'll come back to in a second, that dictate whether logic in the game can operate, and then trying to figure out how to plan very far ahead into the future. Games such as Fear from 2005 is largely, well, first of all, Fear is the game that really brought planning, which is an ancient concept in contemporary AI. We've been doing AI planning for 50 years now, but this was the first time we really saw it in a AAA game. A lot of other variations of this have emerged. Hierarchical planning, task planning, for example, is used in the Horizon games, where you have a very complex task of kill the enemy, but it breaks down into individual groups of behavior, and then those behaviors get broken down even more into individual actions. Meanwhile, games like Dark Souls and Elden Ring use what we call hierarchical goal planning, where it has a high-level goal, and then it tries to break it down into sub-goals, and then finds actions that complete the sub-goals. I don't have time to explain it. I have made a video on the AI of Dark Souls. Go check it out. Lastly, there's utility systems, and that's really when we're struggling to encapsulate a very complex, nuanced aspect of a game's design. We really want to identify the relevance of an item or an action or a value to a character. Games like The Sims are a great example for this. Like, how do you know when a character is hungry? So it's actually computed as a function that over time the character will get more hungry, and at some threshold that means it's a good idea for it to go and eat, because we don't want it to die. But we don't want it to just be eating constantly in the corner. It needs to know when is it relevant to execute those behaviors. And critically, things in this video, one of the points I'm explaining is there's different utility values to different weapons, because a melee weapon will have real value when the player is close versus when the player is far away, at which point, well, using a gun would be far more practical. Gameplay management, more often than not, we actually use all the existing techniques I just mentioned. Left 4 Dead is undoubtedly like the game that kind of set the tone for this going forward. And this uses a finite state machine to control the pacing of the game. It just dictates when enemies spawn and where they spawn. And critically, it acts like a DM in Dungeons and Dragons, where it's actually paying attention to each player, and it observes your stress levels, which is simply the amount of damage that you are delivering with respect to the distance of all the enemies over time. So if you're shooting people from afar, you're not stressed. If you're punching 8 people who are in your face, you're probably stressed. And it tries to get everyone stressed at a certain point. Then it throws all the zombies at you, and then it lets it cool off. It's just a 3-state finite state machine. But critically, the transitions will change based on how you're playing the game. So if you don't observe the rules, if one player runs off and he's like, don't worry, I'm going to solve everything myself, then it will force changes in the state. And it goes, well, you're not playing by the rules. And then you'll notice a boomer hits them, and then a hunter hits them, and then they're dead. So if you're playing Left 4 Dead, stick together, all right? And then lastly, content generation, where we're often using rules and logic-based systems to construct entire parts of a game or an entire experience. You know, No Man's Sky being a great example of a heavily mathematics-based content generation pipeline that builds everything that you see in the game world. I come back to Townscaper. This actually uses an algorithm called wave function collapse, which is a constraint-based search, where it's every time you place a new tile, it tries to figure out what is the possible sets of 3D art assets that it can then place in that point in order to ensure that the shape of the geometry continues to make sense. And subsequently, when it places here, what impact does it have on everything else around it? And in fact, it has to check the entire structure, as you can see it doing right now, because a change in the bottom right could potentially have an implication in the far left. Hard to tell. Anyway. So all of this is really, it's a quick summary. There's a lot more detail. Don't worry, there's 10 years of YouTube videos to catch up on. But I just wanted to paint a picture of what we do here. And in each case, the technology is being used to facilitate a particular goal, because we as designers know the rules of the system. We know what we want. And then from that, we build the search algorithms to actually give us the answers. So we say, here's the problem. Here's the rules of how we're going to find a solution to this problem. Calculate the problem for me, whether that's what action should I take, what path should I go, which of these 3 objects should I interact with. We, as the human, are always coming up with the rules. Now, this actually gets quite complicated. And critically, I want to just point out before we go any further that game AI really exists in this little corner in the top right. When people talk about AI these days, we're actually talking about hundreds of different methodologies. We're talking about over 75 years worth of actual development in this sector, variety of different use cases, algorithms, variations, you name it. But everyone really, when they're saying AI these days, they mean generative AI. It's just a small thing. In fact, it's a subset of a subset of a subset of the entire thing. Okay? Game AI very much exists in its own space and what we call symbolic AI, which is typically rules and reliant on human knowledge. And the thing is that it's great because we as the designer get to dictate how things should work in theory. But that means sometimes when we have very large problems, it's very difficult to search through it. How do we constrain, as games get bigger, how do we constrain the game space in a way that the search can still work? Also, humans are great. I know many of them, but they're also prone to making mistakes. We have flaws. We sometimes don't catch edge cases in our logic, but also sometimes we can't express the logic of trying to capture a particular problem. Like race cars, for example, in games are very difficult to do, and more often than not have used proportional integrated derivative controllers, PID controllers, which are this complex mechanism of handling different aspects of the physics of a car to handle its steering and behavior, because it's really hard to express it in just core rules. And that's where machine learning usually kicks in. So machine learning has actually came around a lot in the last 10 years, if you've been watching what's been happening, particularly in the AAA space. And that's because it helps us capture information that we as humans sometimes struggle with. So the big difference is that unlike before, where we set the rules and we give it the data and say, right, we're going to program ourselves a solution, here I've got the data, I've also got the answers, I'm going to learn the rules. So can I give it a bunch of information, data from the game and say, learn to reproduce this, right? Show of hands, who here knows much about machine learning at all in any real detail? 3 of you, this is great, good, because the next picture's full of cats and dogs. Okay. I bring this up for a very particular reason, because image recognition is one of the oldest problems in machine learning. Can I get a system to recognize a cat as a cat and a dog as a dog? Now, if I was to ask any of you, what does a cat look like? You go, well, you know, it's got ears and it's got a couple of eyes and it's got a little snout and it's got whiskers and yeah, like what does a dog look like? Well, yeah, it's got eyes and a couple of ears and whiskers and oh shit, hang on, no, I've just described the same. What's the nuances? How do we begin to express that to one another? Like, I don't have to explain this to you. If you turn around to me and said, that's a cat and that's a dog, I'd be able to say either yes, or you're crazy. That's clearly 3 dogs. So this is actually a really good way to do it. We give it the pictures have tags attached to them, and we tell it, learn to associate the image with the tag. And over time, as we continue to update the model, it should eventually learn to figure that out correctly. Now, the thing is, we've been doing this for decades, and it wasn't very good because it struggled to capture nuance. This slide always gets a laugh. This is 3 real image recognition benchmarks. Chihuahua muffin, French poodle, and fried chicken, and then Shar-Pei and croissant. And I love it because for many years, it was very difficult to get image recognition to tell the difference. Now we've actually hit a threshold point where this is much easier to achieve. And this is really why we've seen machine learning and in turn then generative AI really blow up in the last 10 years, is the ability to extract these features and capture the nuances of it have become much easier for us to pull off. So this then led to machine learning really beginning to kick off in the games industry. And if you were to ask people, oh, machine learning, AI in games, most people talk about AlphaStar. So this was the project by Google DeepMind where they collaborated with Blizzard to create a StarCraft 2 bot that could play at a human competitive level. As a former AI researcher, AlphaStar is really interesting, and it's a really interesting turning point in how we can start utilizing this technology. As a game developer, this is a terrible example, and it's also kind of useless. The reason for that is that this was reliant on a game that had been around for pushing 10 years. It had millions of active players. It had gigabytes of replay data that they could then get the AI to train on. They had the luxury of using Google Compute resources, and also a AAA studio that was willing to back it up. I had a lot of questions from companies saying, this is amazing. Can we put this in our game? I went, oh, God, no, absolutely not. Like, how far in? Like, oh, we're in pre-production. Like, no, this is insane. Like, AlphaStar benefited from StarCraft 2 being such a big game. And the technology is now moving forward, but really, there's a lot of other really interesting stuff that's happening in machine learning for game development. Also, critically, you ever noticed how that never came back? The long and short answer of it is the meta in the game changed, and it would cost Google somewhere in the region of about another $250,000 to retrain the bots to catch up with the meta. And that's why they only showed it one other time afterwards, and it was at BlizzCon, and they actually ran a rollback version of the game in order to show it on the floor. Had that confirmed from someone inside, I won't say who. But yeah, machine learning in game development, we actually now use it in a lot of different ways. So one of the earliest examples, it's the Drivatar system in Forza, where you have these AI characters that race cars like you do. And this is something that Microsoft have been working on now for about 20 years. I really hope I pronounced Forza correctly, particularly when I'm over here. When you look at games like FIFA, EA Sports, FC, whatever, this is using animation technology where we actually figure out the animation blend trees now using machine learning. This is a process we call motion matching. This is used in a variety of AAA games now, where because the animations are becoming so complex and there's a variety of kinematics being affected on the animation of the body of the pawn, you have to figure out what's the appropriate point to blend from one animation to the other. Trying to do that as a human is exhausting, so more often than not, we try and use AI to do it. Matchmaking in games like Call of Duty. There's a whole bunch of stuff that Xbox now uses as part of the Xbox network with the TrueScale system. They also use it for, I think, is it Dota 2, I believe, also uses it as well. Hang on, I've got it here. Dota 2, Gears 5. Also things like cheat detection in Counter-Strike and Call of Duty is powered by machine learning. Interestingly, the cheat detection, the ML-powered cheat detection system in Counter-Strike is called Overwatch. I don't think they thought that through. Texture upscaling, which we now do in a variety of different forms. So first of all, the Mass Effect Legendary Edition a few years back, when they were moving the games from the Xbox 360 era to the current era, those games actually were running at like 720p if you were lucky. So most of the textures were incredibly low resolution. And so they used generative models to actually upscale them to 4K, and then a human artist went in and cleaned them up. And this, they believe, saved them hundreds of hours in production. It was actually one of the earliest examples of generative AI being used in a video game. More recently, God of War Ragnarok has a neural renderer built into it where they upscale textures in real time using generative models. And one of the reasons they do that is to shave the installation size on your PlayStation. So the textures would have been in 8K and they're absolutely massive, but they ship them on your console in 1080p or 2K, saves you a lot of space, but it still gets the desired effect in the end product. Games like For Honor and Rainbow Six Siege actually use it for gameplay balancing and playtesting. There was some really cool talks about this at GDC this year. And of course, if you have an NVIDIA GPU, you've probably used DLSS at some point, or deep learning super sampling, which is their version of a neural renderer that is using generative techniques to try and upscale your game in real time. So yeah, I've talked a lot about technical stuff. I'm going to kind of pivot a little bit for the second half of this talk. And really, that while the proliferation of machine learning and generative AI, I think is largely, I think as it was addressed in the earlier talk, it's an ongoing thing. And we're not really close to seeing anything pragmatic and useful, I would argue, in a lot of cases. I've actually talked about this a lot of other events. Hopefully I can share some of those at another time. But today I really want to talk about game AI, what I was mentioning at the start of the talk, because I feel it's often left behind. And that is for me a real reason of concern, particularly as someone who's very invested in the AI community. And it's an issue that emerges from the complexity of what we do in a lot of our games, the scale of the challenge that we're trying to address as games become bigger, more complex, more awesome, and in turn more expensive, but also the risks underlying its development. And so coming back to this, like I gave you a bunch of examples of different game AI tech. That's a behavior tree, by the way. So many of these tools and systems, we actually need to kind of rebuild them. every time we move into another production. Like, these are great starting points for building whatever you want. And particularly if you have experience, you have an idea of, we should maybe use this technique versus this technique in this context. But it's all great in theory until I start having to put it into the design of my game. And even if I build one game, my sequel, I might throw it all out because what we built in the first game had so much technical debt. We have to really start thinking of starting from scratch. So we need to think about, is it relevant for our project? Do we need to merge multiple AI methods to get what we want? And the conversation is ongoing, but critically, nothing's really changed, I would argue, for like 10 to 15 years. To that end, little bit of context here. So I'm on the advisory board for the Game Developers Conference in the United States. I actually helped run the Game AI Summit. This is 4 talks from last year. Last year, I had more talks on spatial navigation than I had on generative AI. Now, critically, that's because I helped pick the talks. And if I think a generative AI talk was rubbish, I wasn't letting it in. But it speaks to a broader issue that we have. And I just want to quickly, going in round from top left, and I go clockwise. So the top left, that's Crytek talking about their nav mesh tools in CryEngine. On the right, top right, that is hybrid A-star being used for vehicle pathfinding. In the bottom right, that's actually Giovanni Campo and our own Andrea Tucci talking about the spatial navigation pipeline in Suicide Squad Kill the Justice League. And on the bottom left, that was a post-mortem on the development of Warframe, which has not 1, not 2, but if I remember correctly, 4 different navigation systems based on wherever you are in the game and what you're trying to do. Spending more time talking about how do we revisit and refit existing techniques, because those techniques weren't really built to handle the complexity of the challenges that we're looking at today. Like, not just because he's sitting there, but I really, also I was mentor for the Suicide Squad talk, and I was really interested in this because if you've played Suicide Squad, you're trying to figure out how to get all these different characters to move across an entire environment, and all the existing navigation tools we have and all the vision tools that we have don't work when you have a level that's the size of Metropolis. How do you even get that to work? It's a headache. And this is just a recurring point. And everyone's still using the same stuff that's been around for 10, 15 years. Don't get me wrong, there's a lot of work being done to improve this technology and to iterate this technology, but we haven't had a paradigm shift. And while generative AI and machine learning is solving all these other problems, we're kind of being left in the dust. And I'm glad to say that we're at a point now that AI seems to be coming back into fashion. We saw earlier in one of the previous talks, Souls-likes and roguelikes are really popular, right? Okay, so we need an awful lot of AI-based algorithms to do content generation and NPCs. And this year alone, we've had some fantastic games ranging from Clair Obscur to Assassin's Creed Shadows, Doom the Dark Ages, Elden Ring, Night Rain, all of which require AI behavior as part of their infrastructure, but we're still using 20-year-old tech or older because that's what works. And we haven't really found the next iteration to get us to where we're going to go. And again, I want to say that this speaks to the expertise and the ingenuity of these developers that get the most out of these tools. And it's one of the reasons that I put together our event in London, because this is such a monumental amount of work. I want this knowledge and skill to be shared with the broader games community. But we're a bit afraid now to expand. And none of these are really doing anything fundamentally different. A lot of these are doing the same kind of thing that we've seen before. Expedition 33, it's just kind of Final Fantasy all over again. It's really good. I've cried a couple of times playing it, but it's just Final Fantasy all over again. Like, I don't think we're willing to experiment as much as we used to. I think particularly about going back to what Monolith were doing with the Nemesis system in Shadow of Mordor and Shadow of War. That was a patented design framework built by Monolith that was a framework for NPC behaviors, but it was also for procedurally generating in-game events. It was for narrative generation purposes, and it grounded it all in this really nice narrative framework. So characters had purpose and intent, and they had a reason to come and kill you again and again and again and again. And if they killed you, they would gloat in it. And if you killed them and they were resurrected, they would complain now because like their head's been stitched back on. It's an interesting example that has never been reproduced. In fact, twice in the last 6 months, I tried to move the wrong slide. We've seen two different games that were trying to use this technology that have now been shuttered. Monolith, sadly, has been shut down entirely. They've been working on a Wonder Woman game for several years now that we're using the Nemesis system, and chatting with some of the narrative design teams on it. It sounded amazing. And then literally last week, Cliffhanger Games, which is with EA, cancelled their Black Panther game, which, as I know, was also using a Nemesis-style approach. It's dead, because no one wants to deal with it, because the level of complexity and challenge of getting this to work in the current gaming climate, I think, is too much of a risk for AAAs to really embrace. You know, my YouTube channel has largely been predicated on the fact that people love Alien Isolation, a game that no one has ever tried to really repeat. The closest that came to it is Fractional Games did Amnesia the Bunker, obligatory photo of me in front of a slide with Alien Isolation. Thank you, Andrea. The first time that any studio has really seriously tried to tackle this is Creative Assembly has now acknowledged that they're working on a sequel 10 years later. Like, I'm actually working on a retrospective episode on this. I've interviewed about half a dozen, actually more than half, close to a dozen people on this. And one of the things that came up a lot is we were surprised nobody else tried to do it. But everyone thought it was too risky to try and pull this off. I could debate the finer points of all this because it comes down to risk and cost and investment and returns. And as we saw earlier, the industry's kind of in a mess right now. We'll save that for later on when the beers are being poured. And this kind of gets me to an era where a lot of people have opinions and ideas on how generative AI is going to change the industry. Most of them, and I say this as someone who works with a lot of these companies and keeps up to speed with a lot of this ranges from ill-conceived to uninformed and just downright wrong. I've spoken about this at length at other events. I've also talked about it on my newsletter. You can go and find it there. But I find there's a lot of naive assumptions on the efficacy of these tools rather than a more accurate risk assessment of them. In fact, in our opening talk this morning from Tomas, he was talking so much about processes are what make game studios live or die. Using AI to automate your processes isn't going to help you if your processes are fundamentally broken to begin with. And I've literally worked with companies who were surprised that AI didn't fix their problems. And I said, well, the problems were with your processes before you tried to let AI do it. You need to go back to the beginning and then figure out whether or not what you're automating is actually going to work. Now, I say this, I want to just clarify that I don't think that generative AI has no value. As much as I understand and agree with a lot of the frustrations, particularly the broader sentiment towards generative technologies in games, but also in wider society, I do feel it can and does have value for how we make games. But I think a lot of it does speak to these issues of how generative AI has been sold to the games industry. We've been told, and I'm using that phrase specifically, we've been told this is how this is going to make games better. Last I checked, we make games. So surely we know how to make games better. And we're now in a new wave of this. I think actually, Piero's talk earlier was a really great example of this, where we have a new wave of AI companies coming in who are working with game developers and are seeking game development expertise to understand how these two things overlap. Because what otherwise happens is you have a square peg and a round hole, and you're just trying to smash it in and it doesn't work. Wonderful example of this is almost every chatbot demo I've seen in the last 2 years. Critically, this is NVIDIA's ACE platform, where it's a conversational bot, where you have a conversation with the gentleman behind the bar. So the conversation bit works, but it's really dull. And it's not, it's as a game experience, it's terrible. Because one of the problems that emerges here is because you make these characters more conversant, that they can have a dialogue with you, you as the player assume so much of what that character can now do because they can engage in natural language conversation. They can't move. They didn't plug them into the nav mesh. And they say, well, can you, if you walk to the side of the bar and then say, oh, can you come over here? No, he just stays where he is and just yells at you from, they're like, what is going on? They have no geospatial awareness. And this is the thing that frustrates me, because this is stuff that game AI has been solving for 30 years. We know how to solve all these problems, and we don't need generative AI to do it. So I want to give a very particular example. This is InWorld's Origins demo that was released on Steam last year. It's pretty basic. It's a murder mystery. You can chat to 5 different characters to figure out who might have done it. But to tell a little story, this came out for free, I believe, in July of last year, and I was invited by the company to play the demo before it went public. And the one bit of feedback I gave them was I said, you're launching this 6 months too early. The tech stack works. I can chat with actually, I have trouble chatting with them. You might have noticed I'm Scottish. Speech to text pipelines don't understand Scottish. And I'm in tourist Scotland right now. So I'm giving you my tourist Scottish, where I'm away overseas, and so I'm speaking very formally. If I go back home and go, all right, mate, can you tell us where mother is Ekin? It doesn't work. It tells me what the weather is in, I don't know, Baja. Um, like that doesn't really work for us. But critically, there's so many issues with these characters don't maintain eye lines, they don't move around the environment, they had no spatial awareness. And I said, like, this diminishes the quality of the work that you're doing. If you spent an extra 6 months and doing the game AI part of this, literally hire a couple of game AI programmers and designers, this demo would really blow people away. And they said, no, 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 the strength of it is in the conversation. I respectfully disagree. And like I say, we've been solving these problems for decades. If you gave this to a bunch of AI programmers and designers, they go, oh, I know how to fix all this stuff, or at least like fudge it. Because that's literally what we do. We fudge it. It's called smoke and mirrors. We come up with hacks and little cheats to make things look smarter than they really are. Like every one of you knows the sound that GIF is making. I don't even need to make the sound. You all look at it and go, I know what that sounds like. Because it's a collection of animations, it's a collection of UI elements, it's a collection of sound. And all of those little things process into your brain to help you interpret what happens. So as soon as that happens, your brain goes, uh-oh, we're in trouble. And the first time it happens, that's enough for you to begin to process and understand it. One of the big challenges with AI as a whole, or non-player characters, if I was to go back a couple of slides, is when you look at this, how am I supposed to figure out what each of these characters is thinking? Now, this is a common game design problem. With humans, it's different. I can see some of you right now, and I'm looking at whether you're maintaining eye contact with me, whether you're smiling, whether you're fed up, whether you're hot, whether you're on your phone. And I can tell some of you are like, God, I really hope this talk ends soon. Other people are like, yes, more. So I'm feeding off of that energy right now. Some of you even laughed, right? And that, yes, that's my energy. I feed on that. These are issues of animation. These are issues of barks, dialogue. These are issues of framing. How do I, or like literal theatrical blocking, how do I ensure that the player understands what an NPC is doing based on where the NPC is in the world? Has it got an idle animation where if I'm here and I'm typing like this, you think, oh, this NPC is really busy on his laptop. It's little simple things like that that help communicate what an NPC is doing, because you can't ask the NPC what it's doing. And this, again, we've been doing this for 30 years. We've kind of figured this out. It's not perfect, but we have a lot of rules on how to do it. And that's really where these generative things fall apart, because no one's trying to solve these problems. I swear, these companies can make so much money if they actually listen to me. Hire me. I'm not that expensive. Okay, so I'm going to start barreling towards the future with this. And I wanted to share a little secret. I am worried about the state of the, I'm worried about the state of the industry. I'm worried about a lot of things. I'm worried about politics. I'm worried about how hot it is right now. I'm worried about whether that water bottle is going to blow up. Just America as a concept. But the future of game AI, I think, faces an existential threat. And I don't say this as a knee-jerk reaction to generative AI. Let me stress that right now. It's a reflection of trends in wider society. It's a trend, it's an impact of trends in game development. One of the things we saw in the earlier talk about the state of the industry is how much we've moved towards live service games and online multiplayer, which I believe in turn has had a huge impact on the quality of AI that's being shipped in games, because it's not seen as a priority on the kind of senior business end of what we're building. So as mentioned earlier, I come from an AI research background. I have a PhD in AI for games. I got it 10 years before anyone cared. Well, you got a PhD in AI for games. Why? Now people go, oh yeah, that seems like a really relevant thing to have. But anyway, back in my grad school days, this paper, well, actually, I wasn't in grad school yet. I was actually first year of university in 2001. But this paper by John Laird and Michael Van Lent was published that said that AI is the thing that will change games in the future. And it argued that for allowing more engaging AI characters and systems for gameplay, new types of playable experiences. And the argument was that graphics eventually will bottom out. I mean, they were right. It took 20 years, but I would argue we are at a point now that graphics are largely bottoming out. I mean, I think more people were excited about the Switch 2 coming out than anything that PlayStation and Xbox are going to ship in terms of like overall GPU power. And also, I don't think making, I want to be able to see the pores of my NPC. I don't really think that's something that people are looking for. Look, I can see his arm hair. I don't care. But I think this argument has actually proven inaccurate in some regards. I think it's fallen short because we've used AI in lots of ways, but critically, as I mentioned earlier, we use machine learning in production. And I think generative AI, a lot of the arguments are in production. And potentially we're going to see these other interesting use cases like Piero's talk earlier. I think there's an argument to be said that generative AI could enable new gameplay experiences. We saw that earlier today. But equally, I think it means further investment in how we address the existing problems that we have and how do we bring the old and the new together to try and address this gap. Because if we don't do something about it, we're going to end up in a situation where games are so lifelike, but the AI is still as smart as a bag of hammers in an awful lot of situations, which defeats the purpose of that pseudo-realism. And again, machine learning and generative AI doesn't solve everything, but it could help us augment specific parts of the project. It comes back to this and looking at how we do things and how can we shake things up? Like what type of technologies do we use to solve some of these problems? And how can we blend technologies? And remind ourselves that there is actually an audience craving this stuff that we've done before, and hopefully we can do it again. It's interesting if you ever go on Google and try and search for the games with the best AI, you're going to be hard-pressed to find anything that shipped in the last decade. People to this day still talk about Half-Life. They talk about Halo. They talk about Stalker. They talk maybe about, XCOM, StarCraft, or they start talking about games like BioShock Infinite and Star Wars Republic Commando, where they have these intelligent companion characters. You've got things like Left 4 Dead. You maybe hear stuff about Shadow of Mordor or Red Dead Redemption, a handful of stealth games ranging from Hitman to Metal Gear Solid, Splinter Cell. The common ones that come up, Left 4 Dead always comes up in every example. Alien Isolation comes up in every example. Stop me if you hear a game that was released this decade. And then the number one to this day is still Fear. Fear's 20 years old. And you think, how is it that to this day, when people talk about the best AI in video games, we talk about a game that is older than maybe some people who actually are here, or you're maybe only slightly older than. I have a much longer rant about this, but I think it comes down to the monetization. It comes down to online gaming and the priorities of where we're going. Also, critically, a shout out to Batman Arkham, because that does good stuff too. I think there's a lot of scope for this. I think we saw earlier with the GARP project, like using generative models to do stuff in a kind of Sims-like environment, cozy games, that's a great idea. This was a really interesting project that I just wanted to put out there as a fun one to end on. This was a research project conducted by David Durst, who was a PhD graduate at Stanford. He's just started over at Roblox. This is a team of Counter-Strike bots where they used the traditional actual bot architecture, which is behavior trees, but they move using a large language model, using an LLM. It's what the author referred to as the language model of movements. Because I didn't get a chance to talk about this today, but large language models don't understand texts. They understand tokens. Tokens are numeric. And it understands the relationship between numeric tokens across broader contexts. So the text is turned into numbers. It processes the numbers, generates new numbers, and then that's reverse engineered back into text. Well, that means I don't have to give it text. So what David did was he reached out to a team of esports players and asked them for several hundred playthroughs of Counter-Strike. And he fed positional data into the LLM. And so what it does is now you actually have a team of bots that move like an esports team. It doesn't use the navigation mesh. They actually move around the geometry based on actual positional data of the level. And that's how you notice they follow sight lines, they hug walls, they avoid getting easy attack. They actually do things that an AI bot that uses the nav mesh couldn't do, because most nav meshes have an edge that prevents you clipping into the geometry at the end. So they're actually wall hugging in a way that traditional nav mesh AI couldn't do. This is a really cool idea. Right now, the problem with it is scale. because it took several hundred playthroughs that you had to go and process. It only works on one map. It only works for one team. It only works in one game mode, and it only works when they've planted the bomb. But super impressive. And the really cool thing about it is it runs locally. It can run on a single core CPU. The actual language model is less than 100 megabytes, if I remember correctly. And is built because the point he wanted to make was you can use generative AI to do something existing AI technology can't do on device cheaply, and it doesn't have a huge cost incurred in terms of memory and resource. We actually have an upcoming episode on the YouTube channel with this. I interviewed David a couple of months ago. But also, we need games to ship that can allow us to have a broader conversation about whether or not generative models can be of any use to us. This is probably the most high-profile example. This is Inzoi, which shipped about 2 months ago. At one point, it was the most wishlisted game on Steam. And it's The Sims, but a lot of the conversation and interaction that you get with these characters is powered by language models and other generative models. In fact, there are pipelines to allow you to create animations by feeding them in from your phone. So you create an emote on your phone, it processes it, and then you can get the NPC to reflect that emote. I think the actual quality of this game, I can't say yet. I haven't played it. It's on my to-do list, probably after I unpack my Switch, and then play 80 hours of Mario Kart, but whatever. But I think we need to have a point where these games come out, we begin to see whether or not this is an experience that people find interesting, whether or not this is an experience that we can ship comfortably, whether or not this is an experience that can integrate with existing game AI so that we can do this stuff more quickly, but also whether or not it is financially viable. As we saw earlier with the original Stanford agent project, that was chewing up thousands of dollars chatting with an LLM up on a server. We need to be able to get to a point where these things can run locally, that they can run cheaply, and it isn't going to burn our budget to actually build them to begin with. So yeah, shameless plug. Do I get Inzoi commission? I don't know. But yeah, the point I'm trying to get at is I'm worried, and there's a reason. One of the other big reasons for it is that the AI hotness right now is right at the bottom. It's generative AI. Everyone's talking about that. And now society at large, when we talk about AI, think we mean generative AI. I get really annoyed when people just say AI to me. I'm like, be specific. Are you talking symbolic? Are you talking ML? Are you talking deep learning? Are you talking generative AI? Don't worry, if you just say AI to me later on, it's fine. We're all friends here. But I get really annoyed when business people and investors say it to me. I'm like, do your research and then come back. This is why I don't get a lot of work. I just get very snippy. But it's having an impact on education. Universities are now rapidly transitioning towards machine learning heavy curriculum. We don't really teach classical AI anymore because that isn't in vogue. The demands of industry and the demands of society suggest that machine learning is the thing that we need to teach everybody. But the techniques, the tools, the technologies that we use as game developers, they're becoming increasingly antiquated. And if they're not taught at academic level, if you're not taught this in school, at university, how can we sustain talent in the sector in the long run? If we start giving juniors only generative tools to use in their first job, how can we enable them to become seniors? How do you cultivate talent when you're telling them, oh, just go and generate 20 textures using some image generation model? You're not going to be a useful senior texture artist to me if you can't make a texture without using a generative tool. There needs to be a way to look at this stuff sensibly and understand how we can fit it in, but critically not overemphasize the hotness of the moment. And there's not many resources for this either. You know, critically, when we talk about AI in game development, people think of me. And I'm just one bumbling idiot on the internet who does a bunch of other stuff. There's a handful of textbooks and there's a handful of events in the world. And I know all of them because I either go to them or I know the people that run them. And these are often individual endeavors done by people who are really passionate about this. I try not to say the term passion in context of the games industry because that's heavily exploited, but that is literally a bunch of very passionate people who are only doing this because they believe in it. I could have made a lot more money if I'd went off and worked in some big... I turned down jobs at several high-profile tech companies about 15 years ago because I didn't want to do it, because I wanted to do this, because this is the thing I'm passionate for. Thankfully, I can afford to pay my rent. But it was touch and go for a few years. 10 years of being a stubborn idiot gets you anywhere, really. That's my one message for you in this talk. But more than anything, I feel like we need, as communities of game developers, we need to double down. And so to kind of bring it actually back to one of the first things I said, it's why my friends and I built our event in London, because we need events. We need events like this one to cultivate the knowledge that we have, particularly at a time when communities are becoming increasingly fractured as a result of geopolitical tensions, due to finances, but also in terms of how education is going to dictate the things that we are taught and why we're taught them and how we're taught them. To me, it's all about bringing in the next generation. I'm already in my 40s. I feel like I'm in my 70s, but that's probably just because I do too much. We want to bring in new talent that helps us figure out these issues. A lot of you here are the new generation that is going to figure out these issues. And I'll be interviewing you on YouTube 20 years from now when I'm an old man, like, hello, welcome. But let me stress, I didn't want to end this as an advertisement for my event, but rather, I just hope you appreciate the sentiment of what I'm trying to deliver here. This is why I'm here today, is because stuff like this is awesome, and we need more of stuff like this. All right. And with that, I think we're by and large done. AI exists in a number of forms. Do your research. Make sure you're aware of the realities of what we're dealing with, and again, support ourselves, support our communities, support each other. That's how we're going to move forward with this. And with that, thank you very much. The water dried up. I was very conscious of stepping back there in case I just like slipped off the stage and cracked my skull. I think we still have about 5 minutes for questions. Is that right?
Hey, hello. I really liked your talk. It was very precise and passionate. Everything is machine learning and deep learning. So I have a question. No. Especially in the games, if you can go, I mean, we can play neural network, maybe with some genetic algorithm, instead of like utility AI, or I mean for decision making, instead of using those big machine learning models, can we just use some small neural network and use it for decision making?
Yeah. So to repeat the question, like really thinking about game AI, can we go back a little bit? Can we look at neural networks and scale them down? Even using genetic algorithms, which also, that was why my first machine learning project was evolving neural networks with genetic algorithms 20 years ago. So when I hear that, I'm like, oh, my heart. No, I agree with you entirely. Like there was a phase in which we were really experimenting with small scale neural networks. You look at games like Creatures in the 1990s, you got Black and White. The one I've never had 100% confirmed is Creative Assembly actually used a very small hand-tuned neural network in the original Total War, but I can't find anyone at the studio who's been there long enough to confirm that story. But no, I agree. I think, particularly Piero's talk earlier, like the idea of going smaller, building smaller networks that we can run locally. And, critically, we're still using neural networks. That's what all these like large language models, image generation models, they're all neural network based. They're now just astronomically large compared to the stuff that we were doing 20 years ago. We're talking about, Pierre, I can't remember how many parameters you said. Yeah, you were talking over 1 billion parameters. The first neural networks I trained had about 70, and I couldn't get them to work. But actually, I published a video on YouTube just last week about really interesting stuff that Ubisoft did in Star Wars Outlaws, where they trained smaller neural networks to handle the speeders in Star Wars. When an AI is driving a speeder, it uses a neural network. And these are only tens of thousands of parameters. So infinitesimal versus a lot of large language models, and they're capable of doing the job there. And there's a lot of interesting work that's happening in that space. I think Ubisoft has done a huge amount of work in internal R&D on this, and how do we get neural networks and like more practical small scale machine learning to work in our games. Electronic Arts does a whole bunch of this stuff as well. And so I think critically, it's worth expressing that there is stuff happening in this space. And I think there's a lot of really interesting opportunity with like small language models, like really training smaller stuff, very bespoke stuff. Again, coming back to the talk from earlier where you had individual models that you want to do for specific things, that allows us to handle these complexities that are very difficult for a human designer to express and get into those really challenging game design concepts using that kind of technology. I think there's a lot of scope for that. And funnily enough, most of it is coming from indie right now. You look at most of the games that are actually shipping or have shipped with language models and stuff. It's all small indie teams because they're willing to take that risk now. Coming back to that point earlier about risk in AAA, all these smaller studios are trying to do it because they're hoping that they might be the first one to make it work and make it work big. You had some of the talk games earlier like Suck Up and Retail Mage, but there's 1001 Nights, there's Dead Meat, there's Millennial Whisper, there's AI to You. These are all like chat-based interaction games where you use a language model to interact with the player. But yeah, I think there's scope. I am excited. We should be doing more genetic algorithms. And I'm biased. It's fine. Any more questions? Front here.
I think I will talk.
Yeah.
Great speech and great.
Okay, so the question was, when do I think we'll see the next step in game AI? It's a tough one. I think I see a lot of small stuff happening. I go to a lot of events. I chat with a lot of developers. A lot of developers tell me things they shouldn't, as well, which I can only share so much on stage. But again, I came back. One of the things I really wanted to stress earlier when I said how the technology is stagnated, it is not for lack of effort on the part of so many designers and engineers, I think, do amazing work. And when you see them build something in your favorite new AAA game, and the amount of effort to get something really simple to work half the time is staggering. We are seeing people trying new things. I think critically, like the first real paradigm change that's occurred is Unreal Engine has published state trees, for example, which right now nobody really knows how to use. It's actually one of our outstanding things at GDC. If we meet anybody who knows how to ship a game using a state tree, we're pretty much guaranteed they're going to get on the stage. So yeah, if you worked on state trees, come talk to me. But I think I think it's going to be an interesting situation where someone figures out how to merge ML, I think, and game AI in a way that allows for game designers to continue to have that control, but it fixes all those really small, difficult edge cases that are really, really challenging to smooth over, right? I think, and the problem is that I don't think we're going to see it as like a holistic approach that can just be used in any old game. It's often going to be cases where we're going to ship it in one game and then another game's going to try it and then another game's going to try it and then it's going to stabilize a little bit. Like motion matching, for example, that's been around now since Hitman Absolution was the first game that shipped with that. Then it went to For Honor. Then it went to the Hitman World of Assassination trilogy. It's used in EA Sports FC. It's used in The Last of Us. Pretty much every AAA game now almost uses some sort of motion matching technology. But that's because it got out there and everyone started trying it. Everyone started sharing their collective experience. And I think with a lot of the technologies as it stands now, the more we get out there and actually start trying to embrace it and trying to take on some of those risks, that's when the collective knowledge really begins to take shape. It's why I don't really see generative AI having any substantial impact on games still in terms of the actual gameplay for a while, because we need more games to come out and we need a consensus to start forming on whether or not this stuff is any good and how we can use it sensibly, ethically, morally, safely, and in a way that's financially viable. Okay, I think I am past my time. So with that, I'll be around for the rest of today. If you want to have a chat, I'll be out and about. But yeah, thank you very much for listening and I'll see you later.